Today's video is on jet transforms. In today's video, I am going to explain shifting properties. Shifting towards right side. If z transform of f of n is equal to capital F of z, then z transform of f of n minus k, if it is shifted towards right side, then the answer will be z bar minus k into f of z. See here, if f of n is shifted towards right side for 1 unit, then z transform of f of n minus 1. Here it is f of n, here it is f of n minus 1. The answer will be z bar minus 1 into capital F of z. In place of k, we have to substitute 1 if it is shifted to 1 unit towards right side. And next one, if it is shifted towards the left side, see here, if f of n is shifted towards the left side, so this side, then see z of n plus k is equal to z bar plus k into capital F of z minus f of 0 minus f of 1 into z inverse minus f of 2 into z bar minus 2 plus and so on. See, if f of n is shifted towards left side for 1 unit, then this will be z bar minus 1 f of z minus f of 0. If f of n is shifted towards left side for 2 units, then this will be z square into f of z minus f of 0 minus f of into z bar minus 1. If f of n is shifted towards the left side for 3 units, then z transform of f of n plus k will be z bar minus 3 into f of z minus f of 0 minus z inverse into f of 1 minus z bar minus 2 into f of 2. So these are all the formulae needed for solving the most important problem. And here are some standard functions which you have to keep it in mind for solving the most important repeated questions. That is, z transform of f of n is equal to log of, see here, log of z by z minus 1, and z transform of 1 by n plus 1 is equal to z into log of z by z minus 1. So these are all the properties needed for solving the most important questions using shifting theorem. That is, find the z transform of. So these three are the most important questions. See here, f of n is shifted towards right side for 2 units, left side for 2 units, left side for 1 unit. Here it is, f of n is shifted to left side for 2 units, right side for 1 unit, left side for 2 units and right side for 3 units. So first problem here is find the jet transform of. Immediately, so we have to recollect the partial fractions. So this is 1 by, this is n plus 2 and into this is n plus 1. So this can be written as a by n plus 2 plus this is b by n plus 1. See, this is n plus 2 into this is n plus 1. And here if I take an LCM, this is n plus 2 into this is n plus 1. A times of this is n plus 1 plus b times of this is n plus 2. So if I cancel this denominator, then 1 is equal to a into this is n plus 1 plus b into this is n plus 2. Clear? That is b into this is n plus 2. So if I put n is equal to minus 1. See here, if I keep n is equal to minus 1, then see, this will get cancelled. That is 1 is equal to, this is 0 plus b times of minus 1 plus 2. So 1 is equal to b into 1. So we got the answer of b as 1. So after getting b as 1, so which substitution we have to keep? Again I am keeping n is equal to minus 2. So put n is equal to, minus 2 and see what happens here. This is 1 a into, here it is minus 2, this is minus 2 plus 1 and this is 0, this is plus 0. So 1 is equal to a into this is minus 1. So a we got the value as minus 1. So after getting a and b values as minus 1 and plus 1, so now I am going to substitute here. So this is the a value as minus 1, b value as plus 1. So our jet transforms is transformed as, and see now here, z transform of this can be written as a by n plus 2 plus b by n plus 1 according to our partial fractions. So a value is nothing but, see here, a is nothing but minus 1 and b is equal to 1. So this is, a is equal to, this is minus 1. A value here as minus 1 by, this is n plus 2, and b value is equal to, this is 1 by, this is n plus 1. So we need the Z transform of 1 by n plus 1 minus 1 by, this is n plus 2. And this can be written as Z transform of 1 by n plus 1 minus, this is Z transform of 1 by n plus 2. As you know that according to our standard functions, we know that Z transform of 1 by n plus 1 is nothing but, see, this is Z into log of Z by, this is Z minus 1 according to our standard function. Here, if I consider this one as f of n, so this is f of n is equal to, this is n plus 1. And we need n plus 2. We have to shift f of n towards left side for 1 unit. And this is f of 0. If I keep n is equal to 0, this will be 1. So according to our shifting property, what is this shifting property? Our shifting property is we have to shift for 1 unit. That is Z transform of f of n plus 2. If I am shifting towards left for 1 unit, then this will be Z power 1 into capital F of Z minus this value is f of 0. And if I substitute the same thing here, then this will be Z transform of 1 by n plus 2 is equal to Z into, what is f of Z? So this is nothing but f of Z. So this value is nothing but f of Z. That is Z log of Z by, this is Z minus 1 minus, what is f of 0? So this is 1. And we got the value of Z transform of 1 by n plus 2 is equal to, if I multiply with this will be Z square log of Z by Z minus 1 minus, if I multiply with Z, so this value is Z. So we got the both values, that is Z transform of n plus 1 and Z transform of n plus 2. So here is the Z transform. So I am substituting here, that is Z transform of 1 by n plus 1 here minus Z transform of 1 by n plus 2. So this is equation 1. So this is equation 2 and this value is equation 3. So now putting the second value and third value in this one. So if I substitute, what is Z of n plus 1? That is Z times of. So this is Z times of log of Z by Z minus 1. And here Z transform of n plus 2 is here. That is minus of. This is Z square log of Z by Z minus 1 minus Z. And if I multiply, this will be Z transform of log of Z by Z minus 1 minus, this is Z square of log of Z by, this is Z minus 1 and minus of minus, this value is Z. So if I take this Z common here, this will be 1 minus Z log of, this is Z by Z minus 1. This value is plus Z, and this is the value for Z transform of 1 by n plus 2 into 1 by n plus 1. So here this is the partial fractions. So here we got the value of A as minus 1, B as 1. So A as minus 1 and B as plus 1. So after writing this in the form of 1 by n plus 1 minus Z transform of 1 by n plus 2. So we need the values of Z transform of 1 by n plus 1. According to the standard function, we got the value of Z into log of Z by Z minus 1. So if I consider this as f of n, that is 1 by n plus 1. So the value here is capital F of Z, and f of 0 is equal to, so if I keep n is equal to 0, this will be 1. So I need Z of n plus 2. So here n plus 1 should be shifted towards left side for 1 unit. According to the shifting property, z bar 1, f of z minus f of 0. Z, what is f of z here? Z by log of z by z minus 1 minus f of 0 is nothing but 1. So we got the value of z transform of z of n plus 1 and n plus 2. After substituting, this is the value. And the next important question here is, see here, these are all the asked questions, so definitely these are very important. If you practice, it is also very easy. So here, what is given here? Z of n plus 2 into n minus 1. So if I consider as a by n plus 2 plus b by n minus 1, so this will be 1 by n plus 2 into n minus 1. If I resolve into partial fractions as this, then what will be a value and b value? See, if I take LCM, that is 1 by n plus 2 into this is n minus 1, and here also n plus 2 into this is n minus 1. So a into, if you cross multiply, this is n minus 1 plus b times of this is n plus 2. So if I cancel these two and see what happens here, 1 is equal to a into n minus 1 plus b into this is n plus 2. Clear? Now, which value I have to take? If I put n is equal to 1, see here, put n is equal to 1. 1 minus 1, this will be 0. And therefore, 1 is equal to 0 plus b into, this is 1 plus 2. 1 is equal to b into 3. And we got the b value as 1 by 3. And after getting b value, next we have to substitute some value for finding a. So now which value? N is equal to minus 2. So put n is equal to, see here, n is equal to minus 2. If I keep minus 2 here, 1 is equal to a into, if I keep n is equal to minus 2 here, this will be minus 2 minus 1 plus b times of 0. So this is 1 is equal to minus 3a and a value is equal to minus 1 by 3. And after getting a, b values, now I am going to substitute here. So here this is the Z transform. So now this can be split in the form of a by n plus 2 plus this is b by n minus 1. Clear? So what is our a value here? So a value according to our partial fractions, this is minus 1 by 3. So this is minus 1 by 3 by n plus 2 plus. What is our b value here? Plus 1 by 3. This is plus 1 by 3 by, this is n minus 1. And see, now I have to solve this one. So if I take 1 by 3 common, this is nothing but Z transform of 1 by n minus 1 minus this is Z transform of 1 by this is n plus 2. Now we need a shifting theorem. So according to our shifting theorem, according to some standard functions, we have Z transform of 1 by n as, see, Z transform of 1 by n we have as log of, this is Z by, this is Z minus 1. So here n is shifted towards the right side for 1 unit. So what is the formula for shifting? So for shifting we have a formula that is Z transform of 1 by n minus 1 is equal to, this is Z inverse into capital F of Z. So this value is nothing but f of z. So this value is nothing but f of z. So now the value can be written as z transform of, therefore z transform of 1 by n minus 1 is nothing but z inverse into, what is f of z here? Log of z by, this is z minus 1. So this value is 2 and this value is 1. So I got the value of this. Next I need the value of z of n plus 2. We know that according to some standard functions, we have z of 1 by n plus 1 is equal to z times of log of z by z minus 1. Here we need n plus 2. Now it is shifted towards left side for 1 unit. According to our formula, we have, see here, if I take f of n is equal to 1 by n plus 1 and f of 0 is definitely, if I keep 0 here, this is 1. So according to our shifting theorem, what is the formula here? 1 by n plus 2. If it is shifted to one time, this is z power 1 into f of z minus f of 0. And therefore our problem will be, so if I substitute everything here, then z transform of 1 by n plus 2 is equal to z power 1 times of what is f of z? F of z is nothing but this one, z into log of z by, this is z minus 1. And what is f of 0? This is 1. So therefore our z transform of 1 by n plus 2 value is equal to, this is z square log of, this is z by z minus 1, and again if I multiply, the value here is minus z. Now this value is nothing but 3. So I can substitute the second and third values in this equation 1. So what is this equation 1? So equation 1 is nothing but, so this value, that is 1 by 3 times of z transform of 1 by n minus 1 minus z transform of 1 by n plus 2. So in this, if I keep the values of z transform of 1 by n minus 1, 1 by n minus 1 is nothing but 1/3 times of z inverse into, this is log of z by, that is z minus 1. The second value I have substituted, minus z transform of 1 by n plus 2 is nothing but, so if I multiply with minus, this will be z square log of z by z minus 1, and again if I multiply with minus, this will be z. And therefore see here, so this is the final value, and this can be written as 1 by 3 times of, so if I take this as common, log z, that is z inverse minus z square into log of, this is z by, so this is z by, see here, z minus 1 plus z. So this is the final value, and this is how we have to solve using the shifting theorem. So this is also so important. So this is 1 by n plus 2 and 1 by n minus 1. So here I resolved, I got the value of a as minus 1 by 3, b as plus 1 by 3. If I substitute here and here, this is equation 1. So as you know that according to some standard function, z of 1 by n is equal to log of z by z minus 1. If it is shifted to right side for 1 unit, then the formula is this. This is z inverse of f of z. Clear. And next we need the value of 1 by n plus 2. For that, some according to the standard function, z transform of 1 by n plus 1 is equal to z into log of z by z minus 1. Here I have to take f of n as 1 by n plus 1, and if I keep n is equal to 0, this value is 1. So according to our shifting theorem towards left side for 1 unit, that is z power 1 into f of z minus f of 0. If I substitute f of z as this value and f of 0 as this value, and this is z transform of 1 by n plus 2, and now we got both the values of z transform of n minus 1 and z transform of n plus 2. After substitution, this will be the final result. And the last question here is, see here, find the z transform of 1 by n plus 2 into, that is 1 by n plus 3. So now according to our shifting theorem, so if I shift this according to our shifting partial fractions, this can be resolved as a by n plus 2 plus b by n plus 3 is equal to 1 by n plus 2 into, this is n plus 3. So if I take this as LCM, that is 1 by n plus 2 into n plus 3 can be written as, this is n plus 2 into n plus 3, that is a into n plus 3 plus b into, this one is n plus 2. N plus 2, and see now I can cancel these two, and the equation here is 1 is equal to a into n plus 3 plus b into, this is n plus 2. Now I have to put some substitution. Therefore put n is equal to minus 2. If I keep minus 2, this will be 0. Therefore 1 is equal to a into, this is minus 2 plus 3. So a into 1. So I got the value of a as 1. And next I have to keep n is equal to, see here, if I keep n is equal to minus 3, then this will be 0. Therefore, 1 is equal to a into minus 3 plus 3 plus b into, this is minus 3 plus 2. So if I cancel this one, so b is equal to b into minus 1. Therefore, the b value here is minus 1. So after getting a and b values, now see here, this can be transformed as, so this can be, see here, this is all according to the partial fractions. See, z transform of this can be written as a by n plus 2. Clear? This is a by n plus 2 plus this is b by n plus 3. Now z transform of, what is the value of a here? 1. So this is 1 by n plus 2 and b value here is minus 1. Minus 1 by n plus 3. So this can be written as z transform of 1 by n plus 2 minus z transform of 1 by n plus 3. So this is equation 1. So according to our some standard functions, we got the value of z transform of 1 by n plus 1 is nothing but z times of log of z by z minus 1. Clear? So this value is nothing but f of z. So this is nothing but z of f of n is equal to. So what is our f of n value? F of n is nothing but 1 by n plus 1. What is our f of 0 value? If I keep 0 here, this will be 1. And see, now according to our shifting theorem, according to our shifting property, we need the value of n plus 2 and n plus 3. Here n plus 1 should be shifted to 1 unit towards left side and 2 units towards left side. So first of all, I am going to write this one, that is z transform of 1 by n plus 2. If it is shifted to 1 unit, the formula here is z bar 1 f of z minus f of 0. Clear? Now I am going to substitute here. So if I substitute, then z transform of 1 by n plus 2 is equal to z into, what is f of z value here? That is z into log of z by, this is z minus 1 minus 1. Clear? We got the value of z transform of 1 by n plus 2 as, this is z square log of z by z minus 1 minus, if I multiply with minus, so this is minus z. So this is equation 2. Now if it is shifted to 2 units, then what is the formula here? Z transform of 1 by n plus 3 can be written as z square into, this is f of z minus f of 0 minus z inverse into f of 1. So this is the formula. So now this value will become, see here, z transform of 1 by n plus 3 is equal to, this is z square. What is f of z? So f of z is nothing but z log of, see here, z log of z by, this is z minus 1. What is f of 0? The value here is 1 minus z inverse. So what is f of 1? So if I keep 1 here, see, if I keep 1 here, then what is f of 0? F of 1. 1 plus 1, this value is 2. So this value is nothing but half. So f of 1 is nothing but half. Now this is the third value. So if I substitute n plus 2 and n plus 3 in our first equation, so what is our first equation? That is z transform of 1 by n plus 2 minus z transform of 1 by n plus 3. So this is the first equation. Now if I substitute 2 and 3 in 1, so this is nothing but z square log of, this is z by z minus 1 minus z. And the next one here is, if I multiply this one, this will be z cube log of z by, this is z minus 1. Minus of minus, this is plus 1, and minus of minus, this is plus 1 by 2z. So this value is 1 by 2z. And see, so if I take common, this will be, if I take z square common, this will be 1 minus z into log of, this is z by z minus 1 And next one here is minus z. This is 1 by 2, 2z. See here, if I multiply here, this will be z cube. This will be minus z square. See here, this is minus z square, minus of minus plus z square. So this is minus z square, and here there is minus of minus plus z square into z inverse is z power 1 by 2. So this is z power 1 by 2, and therefore here the value here will be, so this is plus z square. So I am writing here as plus z square. This is plus z square. So this is z by 2 minus z. Z by 2 minus z value here is minus 2z. And this is minus z by 2. This is minus z by 2. And here if I take z common here, if I take z common, this will be z into 1 minus z log of z by z minus 1 plus z minus half, and this is the final answer. This is the final answer. So this is how we have to use the shifting theorem, and this is how we have to solve. And thank you so much for watching. These are very, very important.